Guten Morgen, students. My name is John Jacob Jingleheimer, without the Smith. Silence! Today I'm going to teach you all about the human brain. All with help from my assistant, Luke Skywalker. After he becomes Jedi Master, of course. The first part of the brain we will discuss is the brain stem. The brain stem plays an important role in the regulation of a variety of functions. The brain stem has three parts: the medulla oblongata, the pons, and the midbrain. The medulla controls most of the cardiac, respiratory, vomiting, and vasomotor centrals that deal with autonomic functions, such as breathing, heart rate, and blood pressure. The pons relays electrical signals from the cerebrum to the cerebellum, which deal primarily with sleep, respiration, swallowing, bladder control, hearing, equilibrium, taste, eye movement, facial expression, and everything else pretty much possible. Lastly, the midbrain controls the visual and auditory systems, as well as eye and body coordination. These all make up what is called the primitive brain. Without these, you end up looking like this. Secondly, we have the diencephalon, the region of the brain that includes the thalamus, hypothalamus, epithalamus, prothalamus, subthalamus, and protectum. The thalamus functions include relaying sensation, special sense, and motor skills to the cerebral cortex, along with the regulation of consciousness, sleep, and alertness. The hypothalamus links the nervous system to the endocrine system via the pituitary gland, which controls body temperature, hunger, thirst, fatigue, and the circadian cycles. The cerebellum plays an important role in motor control. It also involved in some cognitive functions such as attention and language, and probably in some emotional functions such as regulating fear and pleasure responses. But its function in movement is more clearly understood. The cerebellum does not initiate movement, but it contributes to coordination, precision, and accurate timing. It receives input from sensory systems and from other parts of the brain and spinal cord, and integrates these into a fine-tuned motor activity. Next, we have the limbic system. And no, by limbic system I do not mean the planets he's from, but simply the set of brain structures including the hippocampus, amygdala, anterior thalamic nuclei, and limbic cortex, which support a variety of functions including emotion, behavior, long-term memory, and olfaction. The amygdala performs the primary role in the processing of a memory and emotional reaction. Alcohol greatly damages this. The hippocampus plays important roles in long-term memory and spatial navigation. In Alzheimer's disease, the hippocampus is one of the first regions of the brain to suffer damage. Memory problems and disorientation appear among the first symptoms. Next, we have the reticular formation, part of the brain that is involved in actions such as the waking and sleeping cycle, and filtering incoming stimuli to discriminate irrelevant background stimuli. In other words, I had no idea Chewbacca was beside me until just now. Now there is also the pituitary gland. It is considered the master gland. Not like how Luke's a Jedi Master, but instead the pituitary gland secretes hormones regulating homeostasis, including tropic hormones that stimulate other endocrine glands. It is functionally connected to the hypothalamus and the median eminence, whatever that means. Next we have the pineal gland. And I know what you're thinking, Dr. Dean, and that's not what it means. It produces melatonin, a hormone that affects the modulation of wake and sleep patterns and photoperiodic functions, which means seasonal functions, but we like to sound smarter around here. Now we come to the most superior region of the vertebrate central nervous system, the cerebrum. And now my friend Luke will help me sing a song about the cerebrum, won't you, Luke? Sure. Oh, let's sing the lobes, the lobes, the lobes. Let's say the lobes of the human brain. There's the frontal, occipital, parietal, and temporal, all of which to control the thoughts of you and me. Hey! Oh ho ho ho. Well, that was just great, Luke. But we didn't really talk about the information that is in the lobes. Let's go over that now, shall we? Here we have a life-size image of the human brain. Now, the lobe's position are as such. The frontal lobe lies in front, right up here, and the temporal lobe lies beneath there, right here. Then on the other side, there's the parietal lobe up here, and the occipital lobe back here. Now let's talk about each of these lobes. The frontal lobe has the ability to recognize future consequences resulting from current actions to choose between good and bad actions, or better and best, override and suppress unacceptable social responses, and determine similarities and differences between things or events. The frontal lobe is made up of two parts, the primary motor cortex and the primary somatosensory cortex. The primary motor cortex has planning actions and refining movements based upon sensory input. The primary somatosensory cortex is the main sensory receptive area for the sense of touch. Next is the parietal lobe, which integrates sensory information from different modalities, particularly determining the spatial sense and navigation. The temporal lobe is involved in auditory processing and is the home to the primary auditory cortex. It is also important for the processing of semantics in both speech and vision. The occipital lobe, the visual processing center of the mammalian brain, containing most of the anatomical region of the visual cortex. Around that is the corpus callosum, which facilitates communication between the two hemispheres. And above all of that is the gray matter. The function of the gray matter is to route sensory and motor stimulus to the interneurons of the CNS in order to create the response to the stimulus through chemical synapse activity. Then, inside that is the cerebral cortex, which plays a role in memory, attention, perceptual awareness, thought, language, and consciousness. Finally, we have the olfactory bulb, which is involved in olfaction, which is the perception of odors. Because let me tell you, this brain stinks.